Hello, this is Nathan with Milestone Scholars here today, and we're going to be talking about angles in geometry today. So again, angles in geometry are really just another fundamental part, and it is key to understand what these terminologies that we're going to be talking about today, because we're going to be using them in future videos. So without further ado, we're going to get right into it. So the first term we're going to be learning about is angle naming. So it's not really a term, I guess, if you will, but angle naming is incredibly important. So let's say I have this angle right here. So ABC, or I label it 1. So how many ways can you think of that you can name this angle? So basically, there's 3 ways of naming this angle, and the first way would just be calling it angle ABC. The second way, we could actually reverse the naming, CBA. Sorry, forgot the angle sign right there. And the third way is, as you can see here, I labeled the angle 1, so you could call it angle 1 as well. So that's the basics of angle naming, and we're going to be using it a lot in further videos in geometry. So although it's simple, it's worth paying attention to. Next, we're going to be talking about types of angles. So we have some types of angles. So first up, we have acute angles. So acute angles just means that they are less than, so let's have angle X right here. We're just going to call it, or assume it's angle X, 90 degrees. So as you can see here, this angle right here so angle X is less than 90 degrees. Next up, we have right angles. So right angles, right here, we're going to label this right. So basically, let's call this angle Y. So angle Y is equal to 100, or measure of angle Y, I should say, is equal to 90 degrees. And right angles are perhaps one of the most basic angles that everyone has interacted with. So this shouldn't be too hard to remember. Next up, we have obtuse angles. So obtuse angles basically means that the angle is larger than 90 degrees. So we're going to label this angle Z. So measure of angle Z is, it is greater than 90 degrees. So basically, as you can see here, it's basically ranging and going up in size, if you will. And the last type of angle we're going to be talking about is a straight angle. And this is an angle that a lot of people have not heard of, but really it's really simple. Draw a line here, and there you go. The angle here, or let's just call this angle A. So measure of angle A equals to 180 degrees. That's just as simple as that. That's just a straight angle. Um, we're also going to be talking about congruent angles. So if you have not heard of the term congruent, here it is. I'm writing it on here right now. Congruent angles just means that 2 angles are equal. So for example, if I have angle 1 here and I have a separate angle 2. So let's just assume that both of these angles are 50 degrees. So if the degree measure of 2 angles is the same, that just means they're congruent. So basically, if the measure of angle 1 equals to the measure of angle 2, it can be concluded that angle 1 is congruent to angle 2. And this is a property that we're going to be talking about in a later video. This is actually called the definition of congruence. So this is really just one of those properties and theorems that we're going to be talking about. but it's good to have in mind. So congruent angles, sum as we sum it up, basically means that two angles have the same measure, which means they're congruent. So we're also going to be talking about adjacent angles. So I'll just write it down here. Adjacent angles. So adjacent angles, if you know what adjacent means, then you would probably know what adjacent angles means. So if I take angle 5 and angle 6 right here. So what can you conclude about these two angles? For those of you who don't know what adjacent means. So if you have concluded that the measure of angle 5 plus the measure of angle 6 is this equals to 180 degrees, you're absolutely right, but the definition of adjacent angles means that the two angles are next to each other, which is the definition of adjacent. It means two things next to each other. So angle 5, as you can see here, is next to angle 6, making them adjacent. Now we're going to be talking, and this is our last term, an angle bisector, and we're also going to have a interesting problem to solve in this topic. So angle bisectors. So if you know what a bisector is, you're going to know what an angle bisector is. So it is really straightforward. For example, if I have an angle here, let's just say this line here, let's call this A, B, C, and D. Let's just say that if this line BC bisects um, angle ABD. This just means that it creates two equal angles. As you can see here, angle ABC would be congruent to angle CBD if line BC bisects angle ABD. So that really is just the basic idea of what an angle bisector is. The definition can also be derived from the name. Bisector just means that it cuts two sections into equal parts. So, well, it cuts one section into two equal parts. Sorry about that. That was confusing. And now we're gonna have an interesting problem to solve. So let's say if we have a line here, line S, we call this line ST, and then we're going to draw an angle here, an angle here. So we're going to call this line L, well, point L, if you will. Point K and A, call this angle 2, angle 1, this one's angle 2, this one's angle 3. So the first part of this problem, so let's just assume that if the measure of angle 1 equals to 7x plus 3, and the measure of angle 2 equals to 6x plus 7. So we're given that all three of these angles are adjacent, and that line AK bisects angle LAT. So take a moment and try to solve. So try to solve for x. And yes, you do have to give it in a numerical value. So if you've gotten the answer now, congratulations, good job. But if you have not, you would want to tune into this. So let's so we're given that line AK bisects angle LAT. So angle LAT here, as you can see, line AK bisects angle LAT into angle 1 and angle 2. As we previously learned that when a line bisects an angle, it basically means that it creates two equal angles that are adjacent to each other. So since 1 and 2 are adjacent, we also know that they're equal. So the measure of angle 1 equaling to the measure of angle 2 would also mean that 7x plus 3 would equal to 6x plus 7. So x equals to 4. Just as simple as that. We're also going to have a second part to this question. So let's just say that measure of angle 1 equals to 2x minus 8. Measure of angle 3 equals to 116. Quite a big number. So we're given, as usual again, this 180-degree angle that's formed here, and all three of these angles are adjacent, and AK bisects angle LAT, and we're also going to have to solve for x. And I'll give you a moment to solve for this. So if you've reached the answer by now, congratulations again. If you have not, you might want to listen into this. So we know that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals to 180 degrees. So since we know that AK bisects angle LAT, that just means that measure of angle 1 and measure of angle 2 are going to be equal. So since we know the measure of angle 1, we can actually replace it as measure of angle 1 plus measure of angle 1 plus measure of angle 3 equals to 180 degrees, which makes it much more tolerable to solve. So 2x minus 8 plus 2x minus 8 plus 116 equals to 180 degrees. So we have 4x minus 16 plus 116 equals to 180 degrees. So 4x, if you subtract 16 from 116, you get 100. So take away 100 from both sides, it would equal to 80 degrees, and x would equal to 20. So there you have it. X equals to 20, and that's the numerical value. And that concludes all of the good stuff and all of the fundamentals of angles. I hope you enjoyed this video, and thank you.